So the materials required here are a laptop, a high-speed internet, a smart board or a screen, and next is, so before we begin, let me start with the warm-up activity. Here you can see the famous scientist Albert Einstein carrying an egg on his hand, and he's boiling a water on a pan. So what do you guess here? Okay, so let me just say the answer here. So this has a big moral, that is, even geniuses forget or make mistakes. So egg and the watch incidents. So it just means to say that though he is a great scientist, he forgot that he forgot to put the egg in the pan and watch the time on the watch on his hand. So instead he did just the opposite. So this means we are not perfect. Sometimes we make mistakes. So according to this, so we have to accept this moral and continue. Move on to the presentation. So these are my objectives. First is plot and explore quadratic function y is equal to ax square. Plot and explore quadratic function y is equal to ax square plus c. Explore how the parameters a and c in quadratic function affect the shape and position of their graphs. Complete the worksheet given at the end. And that now plotting and exploring this function y is equal to ax square. General form is y is equal to ax square. This is the parabola running from the origin as a vertex. Parameter a controls the vertical stretch or comparison and reflection of the parabola. Then steps here are: to plot y is equal to ax square, open GeoGebra Classic 5, go to graphic view. In the input box, type y is equal to ax square, and when you do that, you get the graph like this. So here I am not able to open my GeoGebra as simultaneously recording the video and moving on. It's not working, so I'm just showing the steps as in this mock training. So of course in the GeoGebra I prepared these things and brought it here. So press the enter to get this. So when you do that, you get a slider and a parabola or a graph. That next, in the third step, what we can see is in the slider make a greater than 1 or a greater than 1 and less than 1 and see the changes. You see in the first case when a is equal to 1, so the beginning parabola is there. Now when you make a between 1 and greater than 0, so that is a equal to 0.2. So you can see a equal to 0.2, you see the parabola is getting stretched. That means when the value is between 1 and 0, the parabola gets stretched. Happens next, in the slider make a less than 0. So when you make a less than 0, that is negative 1.2, you see the parabola moves towards the negative direction, in the upside down negative direction. Then and a greater than 0. So when you make a greater than 0, the parabola is at the upper part of the plane, I mean in this axis, so in the positive direction. Then let's see now in the worksheet. So these are the questions to be completed by the participants. So we can see effects of parameter a. If a is greater than 1, the graph is vertically stretched, compressed. Which ones are they? So the answers and observation from GeoGebra activity. When a increases, the parabola becomes dash. When a decreases but remains positive, the parabola becomes this. So to this, since this is a mock training, I am directly taking to the answer. But in real situation, the answer, the participants will be walking out doing the GeoGebra activity and will be answering these questions. So if a is greater than 1, the graph is vertically stretched. If a is less than 1, the graph is vertically compressed. If a is less than 0, the parabola opens down. If a is greater than 0, the parabola opens up. And when a increases, the parabola becomes narrower or steeper. When a decreases but remains positive, the parabola becomes wider or flatter. When a is negative, the parabola opens down. And that reflection across the x. Next is worksheet. Second worksheet is plot using GeoGebra and explore the following equation. So the participants can do this. That is, y is equal to 2x square, y is equal to half x square, y is equal to negative 3x square. When they do this, you can see that the value 1 is greater than 1, that 2, the coefficient here 2 is greater than 1. And so what type of graph you get when the value here is less than 1 half, but it is positive, what type of graph you get? Stretched, compressed, or how is it? Then if it is negative, how the parabola shape, how the parabola behaves. So these things you can explore yourself in the GeoGebra by function. Now, plotting and exploring quadratic function y is equal to ax square plus c. This is the y-intercept form. That means, intercept form of the parabola. So here, in this case, the parabola's vertex will not run through the 0, 0, that is origin, but it will move little bit up from the origin, that is with the value of c. Parameter c causes a vertical translation of the parabola, and the steps given here are: plot the quadratic function y is equal to ax square plus c in the input bar, put it, and you get this type of graph. See, in this, the vertex is not at the origin, but little bit shifted up by c unit on the positive direction, and also a slider is created. Next, in the slider, make c greater than 0. What happens? Observe the change. So when you do that, c greater than 0, then you can see that if you had already a graph of ax square, and if you plot value with ax square plus c, you can see this red graph. Okay, and c greater than 0, if you make it, the higher you make it, the more the parabola will move. Then plotting and exploring this function again. So same way. Now, if in the slider make c greater than 0, observe the change. In the slider make c less than 0 and observe the change. What happens if you make c less than 0? So when you make c less than 0, the graph will move downwards. You can see by the rate in this case. You can see here this part. When you make c less than 0, the red graph shows it is below the x-axis. That means it is in the negative side of the x-axis. Next is, now this is the worksheet for this part of the activity in phase 2. Now let's see, if c is greater than 0, the graph shifts up or down by c unit. If c is less than 0, the graph shifts up or down by c units. The shape and direction of the parabola remains what? Then observation from GeoGebra. Changing c moves the parabola. How? The vertex moves from 0, 0 to 0, comma, what? Then the axis of symmetry remains at x is equal to what? And sample equations you can explore is y is equal to x square plus 3 and y is equal to negative 2x square. See the answer to this worksheet. So we can see here, okay, first one, look, if c is greater than 0, the graph shifts up by c units. If c is less than 0, the graph shifts down by c units. And if the shape and direction of the parabola remains the same. So shape does not change in this form of the parabola. Observation from GeoGebra activity. Changing c moves the parabola vertically. The vertex moves from 0, 0 to 0, comma c, because we change that y to c. The axis of symmetry remains x is equal to 0. Then sample equations you can explore with these two equations using the GeoGebra Classic. My present